Eldora radar. So let me briefly show you the results about the impact. This is the result rerun by Sam Everson, indicating that in this particular time when we have these flights from Star and Falcon, the synaptic surveillance, it shows that there's a significant improvement on the track. So the red is the best track, blue would be the track after the data from the drop zone are assimilated, but the green would be the one without assimilating the drop zone. So there's a huge difference when the data are assimilated. And this happens in September 10 and September 11, 0Z. There's another result which is very interesting, shown by Nakazawa in another conference. He shows that on September 11, actually at that time, all models are showing very good forecasts. But the denial experiments shows, the drop zone experiment shows that aiding the drop zone, the results was very bad. It's even worse. And we found that at that time, there's no more synaptic surveillance. And this degradation is very likely due to the use of the inner core drop zone by C-130. And that is an issue that has been addressed in the paper by Sim last year because of the representation error of the drop during its fall, because it changed the location very quickly. And that was not well assimilated into the current global model. And analysis can be done to see how that happened. Well, here I show you the unsafe GFS results with analysis, initial condition with drop zone and without drop zone. And the main difference here is if we look at the mean structure in terms of tangential wind versus radius, we see that without the drop zone, the storm is weaker and with larger radius of maximum wind. But when the drop zone is included, the storm's feature is stronger and with reduced radius of maximum wind. What is also of interest is the strengthening of the subtropical high outside of the drop zone region, and that would lead to the strengthening of the steering flow to the northwest that can be analyzed through the steering flow analysis and potential vorticity diagnostics. And another feature work we did was to try to develop a new data assimilation technique to be able to assimilate all these drop zone data make use of all these drop zone data. And this is a showcase to indicate how we assimilate all the drop zone information with the wind, surface wind, with radius to construct the mean vortex structure. And all these green dots here indicates the observation from drop zone, and the red is the best track analysis estimation from the JTWC. With that, we can fit it into the curve by Willoughby to have this mean structure, and then we construct the ETKF data assimilation with the three operators, including the position, motion, and also the mean structure I just described for data assimilation. And with that, we have the opportunity to do a 24-hour data assimilation to initialize the model with a more appropriate vortex, and it is also more balanced. And this is a very good way to use the data and then for further study. And actually, during this 24 hours period, the track is also getting much better. Excuse me. So with that, then we use this technique I just described to assimilate all the data in a 5-day or 4.5-day time window continuously, not only with all the drop zone deployed, about 150 drop zones from the special aircraft, plus all the conventional radio zones in the nearby continent areas. Then we can have a very comprehensive assimilation, and we reconstruct the new model data, and which we believe would be the best we can get for this study. So here is the reconstructed data through the data assimilation in the Wolf model, and at a resolution of about 5 kilometers here. And we see that this is the tangent Hofmodel diagram in time and radius. So it shows the mean structure of the tangential wind here. We see the inner eyewall in the very beginning stage, and then the build-up of the outer eyewall and the replacement with the inner eyewall. And this whole process, not only the wind, you can see that from the rainfall, precipitation, and also consistent with some of the observations from the satellites, from the SSMI satellites. And some of the, even though the pressure is not assimilated, but we see that the central pressure, they also agree from the model, agree very well with the observation from the C-130 inner core drop zone. So these points, they match very well, except this one. But so that means we have a very comprehensive and quite wind and pressure balanced results in this. So what is of interest to us is to look at the structure of the evolution of the concentric eyewall here, and of the eyewall here. And if we stop the assimilation at this time and run it later, or stop here or here, anywhere. But let me show you two extreme cases. But first I'll show you the overall results of the reconstructed data set. So here we see that this is the mother vortex with random convection